ChemOrgChem. In this video, we are going to explore titanium trichloride reagent and their basics and applications. If you are new to this channel, don't forget to subscribe to get more updates like this. Let's moving on. First, we are going to see how to prepare titanium trichloride. So this is one of the methods to prepare the titanium trichloride. When you take the titanium tetrachloride with hydrogen gas, you heat under 400 degrees Celsius, you will get the corresponding titanium trichloride. So this is the another method when you take the titanium tetrachloride and react with aluminum under 250 degrees Celsius, which produce corresponding titanium trichloride. Next, moving on the structure. So what is the structure of titanium trichloride? So here you see titanium surrounded with 3 chlorine atoms. So titanium oxidation state is 3 plus. So their color is violet color solution. But titanium trichloride could crystallize various forms. For example, based on that crystallization, we can classify that alpha titanium trichloride, beta titanium trichloride, and gamma and delta titanium trichloride. So next we will see what is the structure of each of these classifications. For alpha titanium trichloride, structure is hexagonal shape, and beta one is fiber or chain, and gamma one is cubic form, and delta one is alternating hexagonal and cubic forms. Okay, let's see how to prepare this each form. For especially the first reaction that produce alpha titanium trichloride, and similarly the second reaction also produce alpha titanium trichloride. But when you take these two reactions, when you heat 0 to 100 degrees Celsius, which produce beta titanium trichloride. And same thing, when you take these two reactions, when you heat under 150 to 200 degrees Celsius, which produce gamma titanium trichloride. When you take the alpha titanium trichloride plus gamma titanium trichloride under grinding, which readily produce delta titanium trichloride. Next, moving on, the applications of titanium trichloride. There are 3 important applications in titanium trichloride, such as McMurry coupling, neet reaction, and Zigler-Natta polymerization. We'll see one by one. First, we are going to see the McMurry coupling. So according to McMurry coupling, carbonyl compounds can be reductively dimerized to produce either diols or alkenes by using low valent titanium. So now you consider this carbonyl compound. When we can use either titanium trichloride or titanium tetrachloride in the presence of reducing agent, which readily produce corresponding alkene compound. Here reducing agent is necessary to produce low valent titanium 0. So what are the reducing agents? We can use either lithium, sodium, potassium, magnesium, zinc, lithium aluminum hydride, or zinc copper couple. So this zinc copper couple we already discussed in our channel. If you missed to watch, don't worry, you can find a link from our description box. However, this reaction produces poor stereo selectivity. That means that you will get the mixture of cis as well as trans isomer of corresponding alkene. However, that slight preference for the formation of E alkenes also noted, since due to some steric problems. Only 2 steps are involved, such as initial phenol coupling and followed by deoxygenation step. The phenol step involving 1 electron reduction from a titanium complex to generate a corresponding ketyl radical, which then undergo coupling to produce this corresponding phenol type product, had a significant support. Notably, phenols could be isolated in high yields when you conduct this reaction under lower temperature. However, the deoxygenation step was unknown at the time. Therefore, the mechanism was more challenging to find. Therefore, McMurry postulated 3 types of magnetic pathways, such as first the 5-member titanosin formation or acyclic variant with 2 coordinated titanium, and third one is hybrid mechanism where the both oxonion coordinate to the titanium surface. Therefore, experiments were designed to differentiate these three pathways. So first you consider this example. So this one is a stereo-defined diol. So when you subject under McMurry coupling condition, which readily produce mixture of cis as well as trans alkene. So this reaction clearly indicated that this reaction undergone by non-constructed fashion. That means that radicals could be involved in this process. So here you see this one is a cis campaign diol. So this one is a trans campaign diol. When you subject under the McMurry coupling reaction condition, both of them produce this corresponding alkene. So here you should note that this campaign diol can easily form a five-membered this titanosin framework, while this trans campaign diol could not form. However, this both reaction undergo equal rate. So this clearly ruled out the involvement of pathway A. And similarly, another experiment that clearly ruled out pathway B. So now you consider this example. This is decalene diol under this condition readily produce this corresponding alkene. However, this trans decalene diol couldn't produce this corresponding alkene product. So this clearly indicated that common titanium surface is needed for this reaction, and ultimately which ruled out the involvement of pathway B. So based on this experiment, now we can see the mechanism for McMurry coupling. So initially titanium trichloride, when you use reducing agent, which readily produce a low valent titanium, that is titanium 0. So titanium 0 present in the surface. So now you see, so one electron comes from here, and similarly, so one electron comes from here and another electron move towards to this carbon atom, which produce this corresponding ketyl radical. So this ketyl radical readily coupled each other to produce this corresponding intermediate. So after that, which readily undergo homolytic cleavage of this carbon oxygen bond. So now you see, which produce this corresponding intermediate radical. So now this radical comes here, then similarly one more carbon oxygen bond cleave homolytically to produce this corresponding alkene along with this titanium oxide byproduct. So next, moving on, some of the examples are based on McMurry coupling. So when you take the cyclopentanone, when you treat under titanium trichloride and potassium, which readily produce this corresponding alkene compound. So not only ketone, if you take the aldehyde, here you see this compound containing aldehyde. When you treat titanium trichloride in the presence of lithium aluminum hydride, which readily produce this corresponding alkene product. So not only homocoupling, heterocoupling also possible. So when you take the cyclopeptanone plus acetone, when you treat under titanium trichloride and lithium, which readily produce this corresponding alkene as a major form, this one is a minor form. And notably, when you conduct this mixed coupling reaction, definitely you should take one of the ketones should be more amount. So sterically hindered or strained olefins which cannot be prepared under this method. However, if it formed, that produce in high yield. Now you consider this example, this ketone is a highly sterically hindered ketone. When you apply titanium trichloride zinc copper couple, which could not produce this corresponding product. And when you see this strained ketone, when you subject under this condition, which readily produce this corresponding strained alkene compound in good yield. So next, moving on, another example. So now you consider this example. So this one is one of the interesting as well as unusual example. So this particular reaction is one of the intermediate for synthesis of taxol intermediate. So when you subject under this reaction condition, which stopped in the diol level, so this probably causing for the ring stain. Imagine if present in the double bond in this framework that may fill the ring stain. In order to avoid the ring stain, this reaction stopped in the diol step alone. So next, moving on, another example, we already seen that if we want the diol, we should conduct this reaction under lower temperature. So this is the one of the example. Now you see this framework having two aldehyde group. When you subject under this reaction condition under 0 degrees Celsius, which produce this corresponding diol product. So intramolecular reaction, we know that our fastest reaction, the formation of 5-member or 6-member ring system. And when you come to the 8 or higher member ring system is considerably slower. Now you consider this example. So this is one of the example for intramolecular McMurry coupling reaction. So one end having aldehyde and another end having ketone. When you subject under this condition, which readily produce this corresponding cyclic alkene product. So next moving on, some more example. So now you see this example having two keto group in the both end. When you subject under this condition, which produce strained alkene product. So macrocyclization also possible in McMurry coupling reaction condition, but we need to conduct this reaction under high dilution condition. So this reaction highly useful for medium or large ring synthesis, and yields are independent. The type of the ring size could formed, unlike in other macrocyclization such as azela condensation. For take this example, here you see here aldehyde, here also aldehyde. When you subject under this condition, which readily produce this corresponding macrocyclic alkene product. So even though there are a lot of application in the McMurry coupling reaction, however, some downfall also there in this reaction, such as this reaction condition do not tolerate the presence of easily reducible functional groups such as epoxide, alpha haloketones, unproducted 1,2-diol, allylic or benzylic alcohol, quinones, halohydrates, aromatic and aliphatic nitro compounds, oxime and sulfoxide, but most other functional groups are compatible. So next we moving on, our next application of titanium trichloride is NEF reaction. So the NEF reaction, the conversion of primary or secondary nitro compounds into carbonyls by using various reaction conditions, but here we are going to see only titanium trichloride condition. So even this type of reaction known as McMurry modification of NEF reaction. So according to this reaction, when you take the primary or secondary nitro compounds, when you treat under titanium trichloride and followed by workup, which produce corresponding carbonyl compound. So next moving on the mechanism. So now you consider this nitro compound, so which readily interact with the titanium trichloride. So now you see this nitro compound here, oxygen has the negative charge. So this one readily interact with titanium and followed by kick off chlorine minus ion, which readily produce this intermediate. After that, now you see this nitrogen oxygen bond cleaved this electron shifted towards the nitrogen atom to produce this corresponding nitroso compound and followed by this titanium byproduct. So after getting nitroso compound, which readily tautomerizes to produce this corresponding oxime intermediate. Once you get the oxime intermediate, which readily undergo hydrolysis to produce this corresponding carbonyl compound. Let's moving on some of the examples based on this modified NEF reaction. The first reaction is here you see compound having nitro compound. When you treat titanium trichloride and water and Gleim condition, which readily produce corresponding carbonyl compound. And similarly, this compound also can easily convert into the corresponding benzaldehyde by using this reaction condition. So this is one of the interesting example. This compound having nitro compound as well as the cyclic acetal group. However, when you conduct under this reaction condition, the cyclic acetal also cleaved to produce this corresponding carbonyl compound, and at the same time nitro compound also converted into the corresponding carbonyl group. In order to product this cyclic acetal group, we can run this reaction by using buffer reaction condition. For example, when you use the buffer reaction condition using titanium trichloride ammonia state water condition, which produce this corresponding carbonyl compound without affecting our cyclic acetal framework. So not only nitro compound, even nitronate ion also could easily convert into the corresponding carbonyl compound by the treatment of titanium trichloride buffer reaction condition. For example, when you take this nitro compound, when you treat with sodium methoxide, which readily produce corresponding nitrogen ion. So here you see, so this sodium methoxide base, which readily takes the proton from this side, which readily produce corresponding nitronate ion. This nitronate ion readily undergo our NEF reaction condition, which readily produce corresponding oxime product, which further undergo hydrolysis which produce corresponding carbonyl compound. So this is the another example for the nitrogenate ion to corresponding carbonyl compound. Now you see this framework having nitro compound. When you treat with sodium methoxide which produce corresponding nitrogenate ion, which then treat with titanium trichloride and buffer reaction condition which produce this corresponding carbonyl compound. So next, moving on, Zigler-Natta polymerization. This is one of the important polymerization reaction, as well as for this Ziegler and Natta awarded the Nobel Prize for their invention. So according to Ziegler-Natta polymerization reaction, hydrocarbon monomers that could readily polymerize to produce corresponding polymer, for example, ethylene or propylene, which readily convert into the corresponding polyethylene as well as polypropylene compound. Another important thing in this reaction is stereoselective as well as stereospecificity. When you compare to the anionic or radical polymerization, which readily produce irregular polymers, but when you use Ziegler-Natta catalysis, most of the time you observe the stereospecific or stereoselective polymerization reaction. So Ziegler-Natta catalysis contains two parts. One is a transition metal compound, another part is a organo-aluminum compound. Especially when you see the transition metal compounds, we can use the group 4 elements such as titanium, zirconium, hafnium, along with organo-aluminum. So here you see this is the common Ziegler-Natta catalysis. Either you can use titanium tetrachloride with triethyl aluminum combination or titanium trichloride with diethyl aluminum chloride combination. However, titanium trichloride is a active species for in this catalytic cycle. So now you consider this common scheme for the preparation of corresponding polymeric compound. When you take this propylene compound, when you use titanium trichloride, the presence of diethyl aluminum chloride as a co-catalyst, which readily produce isotactic polymers. So let's see about the mechanism. Before moving out the mechanism, so there are three types of mechanisms are known to explain the Ziegler-Natta polymerization reaction, such as monometallic mechanism, bimetallic mechanism, and finally Cauchy mechanism. But this Cauchy mechanism is mostly accepted mechanism. Therefore, we are going to see only the Cauchy mechanism here. So before going to the mechanism, we should understand the titanium chloride surfaces. So in our very first slide, we discussed about the titanium trichloride that could present in the various crystal structure forms. Based on, we can present alpha form, beta form, gamma and delta form. So here we should consider the alpha titanium trichloride form. So titanium having 6 orbital in the outermost cell, that means that titanium coordination number is 6, but titanium trichloride only 3 chlorine atom only occupied, and the remaining 3 places are shared with near titanium trichloride, and which makes that this type of structure. So now you consider only this one. So this titanium present in the inner phase, while this titanium present in the surface. So therefore, so this inner titanium surrounded with 6 chlorine atom. However, in the titanium present in the outer surface, which only surrounded by 5 chlorine atoms only. So that means that so one of the place are vacant. So if you struggling to understand this concept, you just imagine this. So this one is here present in the surface. So in the surface, here you see here chlorine atom, here also chlorine, here chlorine atom. The one of the chlorine atom present in the inner side. Therefore, one more site is empty. So in that empty space is necessary for to observe this reactivity. So now you see this titanium present in the surface having the empty vacant orbital, which readily interact with the diethyl aluminum chloride. So now you see this aluminum coordinated with this chlorine atom. At the meantime, this aluminum kicked off one of the chlorine atom, then followed by this carbon and titanium bonding happened to produce this type of intermediate. So this one is one of the active species for this Zigler-Natta polymerization. So after we get the active species, which readily undergo initiation step. So in this initiation step, which readily coordinate with alkene, which readily form the corresponding pi complex. After the formation of pi complex, now you see, so this electron attacks the titanium atom and followed by this titanium carbon bond cleaved. So this electron attack in this carbon center, which readily produce this corresponding intermediate. After the formation of intermediate, rearrangement takes place to produce this intermediate and followed by generation of again vacant orbital. So this quickly undergo propagation step with n number of alkene which produce this polymeric chain containing intermediate. So next moving on, termination step. Termination step, there are several termination methodologies are possible. So here I am going to discuss only two type of methods. The first method is beta hydride elimination to produce corresponding metal hydride. So now you consider this intermediate. Due to the clarity, I just omitted whatever the surrounding titanium species. So now you see this titanium having the polymeric chain. So this one is a alpha carbon and this one is a beta carbon. So when you subject under this reaction condition, which readily undergo beta hydride elimination, here you see how this happened. This hydrogen interacted with the titanium, which produced this four-membered type of ring system, then followed by this carbon hydrogen bond cleaved, and similarly this titanium carbon bond cleaved to produce this corresponding metal hydride species along with again. So next moving on, hydrogenation. This is the another way to terminate the Zigler-Natta polymerization reaction. So when you treat with hydrogen gas, which readily produce this four-membered intermediate, then which then readily undergo to produce this corresponding metal hydride along with this polymeric chain. Moving on, Zigler-Natta polymerization selectivity. I already said that from Zigler-Natta polymerization, we can get the stereo-specific as well as stereo-selective polymers. Let's see one by one. The first one is regioselectivity. So now you consider this pi complex formation. After the formation of pi complex, so this always undergo 1,2 insertion in this space, and that means that titanium inserted only here rather than this carbon due to the steric as well as electronic factor. And next moving on, stereoselectivity. So now you consider this transition state. So this one is a alkene. So this one already present in the polymeric chain with titanium complex. So now this methyl group as well as this methyl group both are present in the transphase. If it happens like this, which produce corresponding synthiotactic polymer, while if this present in the cis form, that produce isotactic polymer. How this cis form is formed? So when you having some bulky groups in the presence of titanium complex, such as now you think about, we use some co-catalysis, aluminum based co-catalysis. If aluminum contains some isobutyl or ethyl group, that makes that this transition state should form cis phase. If it forms cis phase, this produce isotactic polymers. So apart from this, titanium crystal structure, I mean titanium trichloride crystal structure also influences the reactivity as well as selectivity of Zigler-Natta polymerization. So Zigler-Natta catalysis are effective for polymerization of alpha olefins such as ethylene and propylene. Even sometimes dienes also can useful for Zigler-Natta polymerization such as butadiene, isoprene. However, 1,2 disubstituted double bond such as sterically hindered alkene not possible to work in the Zigler-Natta polymerization. And similarly, when you take the vinyl chloride that cannot undergo by Zigler-Natta coordination polymerization, instead that mostly undergo by free radical vinyl polymerization. And similarly, acrylate, when you take the acrylate under Zigler-Natta catalytic condition, which mostly undergo by anionic polymerization. In this video, we seen that titanium trichloride reagent basics and their three important applications. If you enjoyed this video, first share, like and comment. If you are new to this channel, don't forget to subscribe to get more updates like this. So here are the some of the practice problems. When you get the free time, you just give it a try. Until next time, bye bye.